2.3 operations in the number system. So we've talked about rational numbers and irrational numbers. Here's some examples of rational numbers like 1, 2, a half, -4, square root of 9. Okay, those are all rational numbers. Okay, they can all be written as a fraction. Okay, so for example, you could divide that by 1, you could divide that by 1. This is already a fraction. You could divide that by 1. This ends up giving us 3, so you could do 3 over 1, okay, and this is already a fraction. So these all can be written as a fraction, okay, or they have a decimal that ends, so you could write that as 1.0, it ends at the 10th place, or 1/2, 0.5, okay. All of these have decimals that end, or they go forever but have a pattern, okay. Irrationals, for example, pi 3.1415 ... goes on forever, has no pattern, same as the square root of 2. Those are all irrational numbers. Okay, so let's explore what happens if we add two rational numbers. So 1 is rational, 2 is rational, and equals 3, which is also rational. Same thing, 3 is rational, square root of 2, or square root of 4, which is equal to 2, is rational, and they end up giving us 1, which is rational. So no matter what, rational plus irrational is going to be rational. All right, multiplication, the same. Rational times rational equals rational. 6, which is rational. Okay, so no matter what, rational times rational is rational. All right, let's look at rational and irrational. So here 2 is rational, pi is irrational. We add those together, 2 plus pi. It would end up giving us 5.1415926, blah, blah, blah. Okay, so this would also be irrational because it has a decimal that never ends and has no pattern. Okay, again here 1 is rational, square root of 3 is irrational, so 1 plus the square root of 3 gives us 2.73205, 0, ... okay, also irrational. So in any case, no matter what, rational plus irrational is irrational. Okay, and being able to give us some examples, so some of the quizzes or homeworks or the tests, they may ask, given an example of a number that you can add a rational and irrational and give you irrational, or something like that. Okay, multiplying, okay, 2 is rational, pi is irrational, okay, 2 times pi ends up giving us 6.283185, ... So that is also irrational. And 2 times the square root of 3, okay, which is real, and that's irrational. Sorry, not real. I keep saying real. It's rational. Rational times by irrational ends up giving us 3.4641016, ... which is also irrational. So it seems like no matter what, if we multiply a rational and an irrational, that gives us irrational. Okay? And that is always the case except in one instant. Okay? If the rational number is 0, then we would have something like 0 times square root of 2. Well, that gives us 0. So here would be the only situation is when we have the rational number is 0. So this would be rational, irrational. That ends up giving us a rational. Okay? So this is one case when we have a 0 for our rational number. Okay? But other than that, everywhere else, you're going to have something that's always going to be irrational. All right. Irrational times irrational. So this one's kind of these are kind of tricky ones. So square root of 2 plus square root of 2, well, that's 2 square roots of 2. We know square root of 2 is irrational. Okay? So irrational plus irrational ends up giving us irrational. The only case where that wouldn't be the case would be if we have like negative square root of 2, which is irrational, and then we add that by another irrational, which ends up giving us 0, which is rational. Okay? So we'd always have a rational if our two irrationals are their inverse. So basically what you could add together to end up getting a 0. Okay? All right. Multiplying. So this would be irrational times irrational. Okay, square root of 2 times square root of 2. And we could plug that in your calculator, but really that is the same thing as square root of 2 times 2, which is the square root of 4, which is 2. Okay, so here that would be rational. Oops, multiply. God, I'm killing that. Okay. Okay, so that would be one situation where we have an irrational times an irrational, but the case is that they have to be the same. So both irrationals have to be the same. And they have to be square roots. You can't do pi times pi. Pi times pi doesn't give us rational. It has to be like the square root of 2 times square root of 2, or square root of 3 times square root of 3. Okay? If they are not the same, square root of 2 times the square root of 3, well, that's just the square root of 6. So these are all irrational. Okay? So it depends on what their irrational numbers are. Okay, and then imaginary versus real. So here this would be real. This would be imaginary. Okay, and that ends up giving us, it's not going to be real or imaginary, it's going to be complex. Okay. 3 plus 0i. Well, this is also complex, but since our imaginary is 0, it would be real, purely real. Okay? Versus, I guess we have multiplication now. I mean, if you had it the other way too, you could have 0 plus 2i. That would be purely imaginary. Okay? And then multiplying 3 times 2i, that gives us 6i, which is purely imaginary. Okay, and then 0 times 2i gives us 0, which gives us purely real. Okay. Another cool thing that we're going to be learning about really soon is if we have, well, let's get to that. Here, we're coming about to it. Okay, so we can add and subtract complex numbers just like we do with polynomials. Okay, just like we did on day 1 in unit 1. Okay, so for example, we want to combine like terms. So here would be a constant, and here would be a constant. So these are the real numbers. We could add those together. That ends up giving us 8. And then maybe we'll use triangles. This is supposed to be an I. Okay, so we'd have negative 9i minus 7i. That ends up giving us negative 16i. Okay, so we just combine like terms. We just pretend like I is a variable. Okay, and just how we've talked about complex numbers, we always write the real, and then we have the imaginary. Okay, so in the past we talked about standard form, okay, where we have the highest exponents first, but this isn't the same because we treat them like they are variables, but they're not. Okay, so real, then imaginary. Same thing you may make a mistake is you need to make sure you distribute that negative. So negative 1 minus 3i minus 3 plus 6i. So a negative times a negative gives us our positive. Okay, then we'll combine like terms. We'll do our reals, -4, and then we'll do our imaginaries. That gives us a positive 3i. Okay, pause and see if you can do these ones by yourself. Okay, distribute. So here would be 10 minus 15i, and then we distribute to give us a positive 8i. Then we can combine like terms. We have 10 and then minus 7i. All right, and then last with D, distribute. Make sure you distribute that negative. So we have 3 plus 9i minus 10 plus 5i. Okay, and again, if we just have a negative or a positive, you can always put a 1 in front if that helps you multiplying. Okay, like -5 times a -1 gives you a positive 5. Okay, all right, and then we just combine like terms. Here's our reals. That gives us -7. And then we will combine our imaginaries, which gives us positive 14i. All right, and now we're doing multiplying complex numbers. So again, you do the same thing that you did with polynomials. If we were multiplying something like 1 plus, or I guess it would be a little different. We'd do something like x plus 1 and then multiply it by 2x minus 1 or something. You would still FOIL to all terms. Okay, so here we'd do the same thing here. We would distribute. That gives us a positive 49. Because we don't need to have that positive written there. 49. And then we distribute to the -4i. That gives us a positive 28i. And then we'd multiply our inside terms. That gives us a -14i. And then we'll multiply our last terms, which gives us a -8i squared. Okay, so we kind of talked about this before. We know that I is equal to the square root of a -1. Okay, so we can also figure out what I squared is. So if we squared both sides, that cancels, and we get I squared is just -1, and that's what goes right here. Okay, I squared is -1, so all you need to do once we're to this point is we would substitute. So we know that I squared can be substituted in for -1. Okay, so we'd still need to combine like terms. So we have 49 plus 14i minus 8 times a -1. Okay, so we just substitute what I squared is, which is -1. And then this ends up giving us a positive 8, and then we would combine like terms. That would be 57 plus 14i. Okay, so let's do another example. Pause if you can and do the rest, and then see if you can do it by yourself. Okay, distribute. Again, if you like using a box method, that's fine, or sometimes people like to, you can also do this, which is kind of the same thing. So -6 minus 2i, and then multiply it by a 6 plus 8i, and then you just multiply it like, just like regular multiplication. So you could multiply this. That gives us -16i squared, and then we could multiply that, which would give us -6 times 8 is 48i. And then we can multiply here, which gives us a -12i. And then multiply here, it gives us a -36. And then you just combine, you add them right above 16i squared. Here that would be a -60i. And a -36. Okay. So lots of different ways to do this, all right, and then we know that this is going to be times a negative 1. Okay, that gives us a positive 16, and then we'll combine like terms. That will give us a negative 20 minus 60i. Okay, so it's the same steps that we did before with polynomials, except we're just substituting what I squared is, and then simplify some more. All right, remember if we have something squared, we're multiplying what's underneath itself that many times, so we'd need to make sure we write it as 4 minus 2i times 4 minus 2i. If you distributed like that, you would get the wrong answer, so make sure you FOIL. Okay, so here FOIL would get 16 minus 8i minus 8i and positive 4i squared. Okay, combine like terms, that will give us 16 minus 16i plus 4 times negative 1, which gives us a positive or a negative 4, and then we'll combine like terms. So that will give us 12 minus 16i. All right, D, same thing, okay? Just doing lots of examples. Make sure you're understanding. Okay, minus 10i. Here would be a positive 10i. And here we'll get a negative 4i squared. Okay? One kind of cool thing is if you have the same thing in the parentheses, except the only difference is a positive and a negative, is that those will cancel. And we'll end up getting 25 minus 4 times a negative 1, or 25 plus 4 equals 29. Okay. E, okay, it's very similar to what we did right before. So distribute, that gives us a negative 16. Here that gives us a negative 20i. This will give us a positive 20i. And that will give us a positive 25i squared. These combine like terms, they cancel. Negative 20i plus 20i gives you 0i. So we have negative 16 plus 25 times a negative 1, or negative 16 minus 25, which ends up giving us negative 41. Okay. And then F, I think this is the last one. Okay, same thing, distribute, positive, I guess I'll need to write the positive, got 5, and then distribute to a negative 4i, distribute to negative 30i, and then a positive 24i squared. Combine like terms, so we have 5 minus 34i plus 24 times negative 1. Okay, again, I squared is the same as a negative 1. And then we combine these like terms. So 5 minus 24 gives us a negative 19. Okay, minus 34i. Okay, all right, so I think that's everything we covered. Next time we'll be reviewing, and then on the next day we'll be taking the test. That will be Friday for A days and Monday for B days. All right, and this one should go pretty quick with the test as well. All right, we'll see you.